Welcome to this episode of Conscious Design. I'm your host, Ian Peterman, and author of the Conscious Design book. And today I'm excited to have Martin. He's the CEO of KraftBlock. They are creating a greener system for storing energy, which we need a lot more of in the world. So welcome to the show.
Thanks a lot, Ian, and thanks also for this wonderful introduction.
Yeah, so everybody loves a good origin story. What is the origin story of KraftBlock? How did it come about trying to tackle such a huge problem?
Yeah, it definitely is. Actually, this original story is unfortunately not like just a snipping story. So I have an idea and I will do a project, build a business based on this. It's more a combination from different events in the past that I had. And my last stations in the career, I was working somehow in the interface of sales and R&D of special ceramic products for steel, glass, ceramics industry. So always high temperature applications, which means I have seen quite a lot of energy wasting over that time. But it was not my job to think about energy waste and how to use it again. So it was just somehow in my mind. And years later, but it was already in 2008, I saw a TV report about a heat storage made of concrete. At that time, it was invented in Germany by DLR and Süplin, construction company who was looking for a new application for concrete. And I thought, well, that's pretty interesting. Well, cheap material, you can cast it in each shape, available worldwide, and it stores energy. Pretty good. But why do they only go up to 1 to 500 degrees C? Why don't they store at higher temperatures? When you're working in steel industry, you are used to 1000, 1500, 1600 degrees C. So those 500 degrees C were just a kind of warm up temperature, in my opinion. That's why I called the developers and asked, what is your problem? Why don't you store higher temperatures, higher energy levels? So we discussed about it and ended up with concrete is the issue. So the material that stores was also the issue on the materials point of view, right? From that point in time, it was for me a little bit like scientific challenge, how to figure out how to improve concrete, right? So not watching Netflix series in the evening, but reading literature, thinking about this problem, but still not having any business in my mind, right? So a couple of years later, I had an idea how to improve the material, how to spread the temperature to very high temperatures with very good capacities and things like this. And then underconsciousness started to work, right? Thinking about energy waste in different types of industry, thinking about where's the energy coming from to produce heat or to generate heat. And I was digging more and more into the heat market itself. And I found, well, we need a solution. 80% of the heat which is produced worldwide is generated using fossil fuels. And at that point in time, it was a no-brainer for me to say, if we can decarbonize this process, we really make a huge step in our race against climate change. And that's how it started. So the story is something like 8 to 10 years from there is something till I found it.
Yeah, well, I think it's good for people to hear that, because we hear about the fast ones like, oh, I had an idea and then I started a company and then I'm a millionaire and I solved the problem. And there's we shrink it down into this really small time span. But there's also things like what you've come up with that sometimes it just takes a little bit longer. You got to think through, right? I mean, you identified, oh, here's this technology. Takes a while to figure out, oh, it's the material that we need to improve, right? It's not always this, we like the really straight line to a solution. It feels good. It's great. But it's so rarely that easy of a path. Now, one of the things when I first found out about you guys and this whole space, there's not a lot about that people at least talk about, generally speaking, around the waste heat that happens. And you touched on a little bit, like the steel industry and things like that. It takes over 1,000 degrees of temperature to be able to operate, right? You don't just forge steel in a couple hundred degrees. You're very hot. And so there's obviously waste in that. What the steel industry is one kind of, can you talk a little bit more about the whole, how's there the heat economy, as you mentioned? Yeah. Because nobody's talking about it really, at least not,
exactly.
Not in general, but it's there.
I think that's a kind of psychological problem with us as human beings, because we are used to electricity, right? We turn on the light, we charge our smartphones, we charge our notebooks, we put electronics in standby mode. So you are aware of electricity because it's everywhere. On the other side, heat is also everywhere, right? But you think about it, if it's too cold in the winter and you turn off your heating system to make it a little bit more cozy in your flat. But that's, if you are honest to yourself, that's the only point in time when you think about heat. And just for a glimpse of a second, means the awareness for thermal energy, for heat, is extremely low. And that's more or less the same as for industries. In the past, they could buy their primary energy like gas, oil, coke, for nearly nothing, right? So if you pay 2 cents per kilowatt hour of gas, it doesn't cost anything. So we can use it. We do not have to think about waste heat recovery. We do not have to think about energy efficiency. But the thinking started changing within the last, let's say, 8 to 10 years. It continuously started and progressed till today. But in a technical process, let's assume ceramics, right? You have your mug at home, you drink your coffee or your tea with. This material is sintered, is fired in a furnace, in a kiln at the end. So you need energy to make it hot, which is usually gas. Technically seen, only 50 to 60%, if you have a very, very modern system, up to 60% of the energy is going into your mug itself. The rest is wasted, it's going through the chimney. But people didn't think about this rest of energy that's going through the chimney, right? And that's what we have to think about.
That's horribly inefficient.
It is.
Well, at least, especially as you're saying, is you're comparing it to like electrical efficiency, right? I mean, it's more like 80, 85 is kind of the minimum efficiency level an electrical system would be. We would expect it to be. Wow.
But also electrical system, I mean, also there we have to be honest. I mean, this efficiency we do have with renewable energy. So generating electricity directly from wind turbines or PV cells. If you go back in the past, in the history, you generated electricity burning fossil fuel, coal, gas, oil, generating heat first, and then driving your turbine in your generator to generate electricity.
Right.
So it's a mix. It's a transition to what we have today and what we'll have in the future. Yeah.
And so talk a little bit about your system. How do you address, there's this waste heat? What are you doing, and what generally can you do to a system to even make that more efficient than, we haven't really put brain power to it yet until you see you are, but.
No. At the end, it's quite simple. You have to create the awareness of those people, of those persons operating the whole system for the customer itself, right? As I said, in the past, nobody thought about energy prices because fossil fuels were cheap. There were no carbon dioxide fees, no carbon dioxide tax, no sustainability issues, nothing like this. And this is massively changing at the moment. What's quite interesting also for us to experience is that most of these companies say, we do not have high-grade waste heat. Our waste heat potential is like 100, 120 degrees C. That's true if they do their measurement at the chimney. But if they would do their measurement directly behind the furnace, there would be a different temperature. So if you burn your calcinate, your fire, your sinter, your mug at 1200 degrees C, there definitely is 1000 degrees C directly behind the furnace.
Right.
What technology is doing today, they are diluting this high-grade heat with ambient air, so they cool it down to make the waste gas purification. So remove dust, remove SOx, remove NOx. And then they try to use it. But this means they have to degrade the heat from 1000 degrees C down to 300 degrees C. And that's incredible, because if people would be aware, there's 1000 degrees C. With 1000 degrees C, I could generate electricity. I could use it to calcinate, to sinter. I could use it to dry. I could use it to produce even cold if I'd like to. There are much more opportunities if you recover high-grade heat compared to the low-grade heat coming out of the chimney. As soon as the people understand this fact, they start thinking, well, true, I do have 40% of waste heat. I cannot use most of it because it's too low grade, too low temperature for my processes. How can I get access to the 1000 degrees C, to the 800 degrees C in the high grade stream? And that's what we help the customer with, to explain them, okay, you can recover it by this, you store it, then you can use it for X, Y, and Z.
Right. So just from like a systems thinking, it's really been focused on how to cool it as quickly as possible so you can filter out for pollution and health and safety of the air that you're ultimately pumping out, but you're coming and going, but we can grab this heat and use it while it decreases in temperature, and you're inserting this extra process
Yeah.
to recapture that. And then you can tack on, I imagine you still tack on the filter at the end because you'll have
Exactly.
used all that temperature energy and then it's cooled off.
That's the way it goes. Yeah.
Very simple. It seems like when you lay it out, it's like, oh, this is a no brainer in this, because one of the things you mentioned is storage. So most people, we don't think of heat storage as a thing, right? Most people think of storing electricity, right? We're surrounded by batteries. Like we get that idea. We even get the concept of storing water and
Yeah.
potentially water energy, right? Because there's hydro dams and we have reservoirs and things like that. What is unique and what are you doing with the heat storage? And how does that? Because most people think, right, you stick your coffee mug out and it's just gonna cool off pretty quickly. That seems like a bad way to store
it
energy.
Is,
So
now, heat storage itself, it's quite old technology, right? We used water as heat storage in the past. So especially seasonal storage for district heating systems are water-based. So you charge them during the summertime, you store it till the winter time arrives, and then you discharge the heat from the water to the district heating system. Very simple one. That was also in the past, in more or less ancient times. People, if you go back even to the medieval times, people used hot stones in their beds to have a cozy temperature in the bed during the night in the winter, right? This also was a heat storage. Was not a professional one, but is a kind of heat storage. So storing heat, storing thermal energy is quite old story, but we need it now, because if we take a look, just now a bit of statistics, right? If you take a look to the energy demand of a country and split it into heat, into electricity, and into fuels, usually more than 50% is heat demand. It's not electricity, it's not fuels. 50%, roughly 30% is going on industrial processes, and the rest is going on private homes, for example, just heating, hot water systems, things like this. So there is a huge demand of heat, a huge need for heat in our daily life. Independently, where you take a look at heat storages, as I said, hot water storage, it's quite a common system. When we talked to customers 3-4 years ago, they said, oh, pretty good, 120 degrees C hot water storage. Huh? Now I'm just aiming for your 800, 1000, 1200 degrees C in your flue gas stream. How would you love to do this? So we explained how we're doing it in special heat storage materials like the ceramics. It can take the high temperature. It does not degrade. It's completely stable. And if you need the heat again, you just take cold air through the storage device. It takes up the heat, takes it to your process. That's more or less it. But the unfortunate situation with heat is that heat is not heat. I mean, you have heat in terms of hot water. You have heat in terms of steel, heat in terms of frying oil for potato chips, heat in terms of hot air to roast coffee. It's heat, but these are different applications. And that's why it's quite hard to grab for people. What is heat? Why do we need the heat storage for different applications? And that's one of our, we always say, educational tasks, to do a kind of market education. Why do we need heat storages today? It is because a lot of batch-driven furnaces are integrated, batch-driven processes are integrated in industrial process, right? Heating up, cooling down, heating up, cooling down. And if you put a storage in between, it could levelize this heating up, cooling down. It could smoothen the curve. It could flatten the curve. It could support with using waste heat in the same process again to save gas at the beginning of this process. And you have to create this awareness. Then it's easy to understand why you need heat storage.
right. Well, it sounds, because it's always, like you mentioned, those processes. There's so many that you have to heat up a lot, like forging steel. Like you do that quite a few times before you get an end product. So it's being able to stabilize that. Now, you mentioned temperature wise. So you're able to store up to, I think it was 1300 C.
Yes.
Is that your, now, are you able to use that in some primary processes, or is it typically more like what you said, where you're maybe using steel again, maybe you're running at 1600 C as your first, but what you're doing is capturing it for secondary processes more so? Is that accurate, or?
Now we need a bit of time. Yes and no. It's a precise answer to your question. If you talk about waste heat recovery, It's completely true. I do have, let's say, I have my process at 1400 degrees C. I do have waste heat at 1200 degrees C. That's why I cannot fully cycle it back to the primary process. But I can use the heat for another process, which is not the same. So I fully can replace energy of the second process using my stored waste heat as a primary process, right? That's why there is already a transition. Second point, you can circle it back. Let's say 1400 degrees C, you store at 1200 degrees C, and then you just have to heat up the 200 degrees C, which saves already a lot of fuel for this process. That's the point with waste heat. Our system, or the beauty of our system, is that we created a storage platform. That means the storage for us is always the same, independently of the application. Means we could also charge, and that's what we are doing in one bigger project now, by electricity. So converting electricity to heat, store the heat, and then deliver it to the process. In this case, I can create primary conditions. Means if I have to sinter at 1400 degrees C, I could heat up my storage to 1400 degrees C and deliver to the application. So that's why I said yes and no, and we need a bit more time. Same storage, different application, waste heat, usually for secondary processes, using electricity, also for primary ones.
Hey, it's Ian here. So glad you're enjoying this episode of Conscious Design. If you want the full scoop on conscious design, what it is, how we do it, how you can do it, then check out our book. We wrote it so creative entrepreneurs like you can code social and environmental responsibility right into your brand's DNA. You can download the first chapter for free. Link is in the description. Enjoy the rest of the episode. Don't forget to like, subscribe, and share.
Right. So when you're explaining this to people, is there a similar storage system like pressure or, hydraulic? Is there another system that's pretty similar that people can, they're in industry can click to and go, oh, it's like this, it's just heat, or is it unique and it's
Let's formulate it this way. Our system as it is unique, having this flexibility and a standardized storage in the middle. So we really don't care about the application, right? We could store electricity in terms of heat. We could discharge as heat. We could discharge another discharging module back to electricity. So electricity to electricity, power to power is possible too. We could use waste heat to convert it to process heat or convert it to electricity, what else the application is. And that's quite unique with our storage. Thermal energy storage, there are quite a few in the market. So we are not the only one in the market. This would be marvelous. But on the other hand, it probably would also mean there is no interesting market if there's no competition. So really happy that there is a good competition. But let's say for the high grade heat, higher than 1000 degrees C, I think there are only 3 or 4 players in the market worldwide. Storages below 500 degrees C, you will find 15 to 20 players in the market. But they all aim for different types of application, not the high grade ones, which really use a lot of energy.
Got it. And so you really, really don't care about application or, where the heat is even coming from or where it's going. You're able to, as easily as a battery, be able to just plug into whatever it is that's there. You're able to plug in and go, create, you can even heat that up directly, which is, which I would imagine if you're able to do that, you could choose what power is going to be cheapest, right? You could buy it optimal. Like you said, if you use electricity to heat it up, you could buy it during the cheap hours, right? Rather than prime busy time and even be able to help.
Yeah.
Is this something that cities are even looking at? Because I would imagine this would help even out the load, right? Because in those peak times, the electrical load on your grid.
That's the principle you mentioned is more or less exactly the same that we execute with Nico and PepsiCo in the Netherlands at the moment. Well, I think that's our lighthouse project, also in terms of commercial size at the end, and also in the market. I think it's the largest high temperature energy storage that is under construction at the moment. The aim in this project is that PepsiCo wants to decarbonize their snack production. So they are frying Lay's potato chips in this plant. And to heat the frying oil, they're using gas at the moment, right? And this causes carbon dioxide emissions, and quite a lot. They want to decarbonize this process to reduce Scope 1 and Scope 2 emissions in their own production lines. And our suggestion was, let's use renewable electricities. And now coming exactly to the point you mentioned, when the prices are down, which means our storage just charges for maximum 4 hours every day. and the storage is fully charged, so we can supply the PepsiCo plant 24/7 with heat to heat the frying oil to fry the potato chips. And so you can decarbonize also snack industries in one single step and save up to, 16,000 tons on carbon dioxide per year in this one single plant.
Just on one snack plant. That's
just one snack plant.
That is impressive. I had no idea. I can see why they would want to decarbonize that. That's a lot of carbon for some potato chips.
Oh yeah. 40 tons on potato chips every day.
And you have the numbers. Wow. That is a lot.
Mm-hmm.
That is great. Because one of the things that people talk about too, right, is if you're looking at renewable energy and sustainable energy, one of the things is things like wind, which doesn't always blow consistently at the same time, right? And solar, it's only good when the sun's out. So being able to have a capture system, especially for all the heat processes that somebody uses, you don't have to. I've talked to other people they'll do systems where it's a battery, right? You move it to a battery and then you move it out, but then you're still having to generate heat, possibly just straight from the battery rather than having a more direct line straight to heat.
Right. Yeah.
Which every time you convert energy is bad. You lose. You lose energy at some point, right? If you move it into a battery, every time you move it, do something to it, you lose. There's some inefficiency there. So you're able to cut that down, which is amazing.
Yeah, that's true. And also let's say the lifetime, the service life of a thermal energy storage, it's much bigger than the one of a battery storage, right? So battery storage is, say, something 4,000 to 6,000 cycles.
Okay.
If you're lucky with. Our thermal battery storage is designed for at least 15,000 cycles. And we tested it for this 15,000 cycles without any degradation. So it might last for another 15,000 cycles. Means the usage or the use time and also sustainability in terms of systems design is much, much better than battery storages.
Right. You're able to last 3 times as long and not need any repair. And I would imagine that the degradation would be pretty minimal because there aren't a bunch of like moving components to the system, right? It's more material and heat.
Exactly. For the storage, it's just the material, it's the heat, it's insulation, but that's not an issue. To operate it, you just need a fan. So the fan is the rotating equipment in the whole equation. But
so you have a fan, I think. That's pretty minimal in terms of wear items in a system. So I would happily just replace a fan. That's all you can do to keep using it. Or what's the most interesting application you guys have been approached to do or worked on? Potato chips are interesting as well. Never would have thought of that. But anything else that's really struck you guys as unique and interesting application for this?
I think there are really several ones. Let's say we do have, for example, also 2 projects under execution in the steel industry. And steel is one of the biggest carbon dioxide emitters that we have worldwide. So cement is much better, of course, but steel industry is also one of the biggest. And maybe if you ever drove by a steel plant, you see this flare gas stack burning into the atmosphere. This looks like a wonderful small candle, but it's not a small candle. It's more like a flame height of 50, 60 meters and burning with 30 to 50 megawatt of capacity. That's extreme. So a lot of energy just wasted fully directly into the atmosphere. And we designed a system that is able to recover this energy. So we do not have to flare it into the atmosphere. We flare it directly into our storage, and then we can use it. And the basic idea is that the storage at the end is just a buffer, right? The flare gas stack is firing 2 hours every day, maybe only 4 hours every week. If the production is working pretty good, the better it's operating, the more flare gas is getting flared. So it's not a continuous process. It's not plannable at the end, but we can take it as it is, put it into our buffer. Storage is nothing else but a buffer, and then discharge to the application even 24/7. What is that interesting at the application? It's really not plannable. It's high temperatures, high charging powers. Our system is designed for this. And now I place another figure, 1,400 terawatt hours if I translate it to the energy demand of Germany, it would be in a full energy supply for 6 months for whole Germany. 1,400 terawatt hours of gas is flared into the atmosphere by the steel industry and oil and gas industry. And it will be still flared in 5 or 10 years because the change processes are quite slow in those industries. Means if you are able to recover that and take it back to any other process, that's really amazing.
That's a lot. That's a lot of power.
It is.
That's that I feel like that's hard too, right? Because it's not plannable, right?
Yeah,
What you said it varies, so that's usually hard for a system to handle. Which is probably why they just burn it off, because they just need to get rid of it at that moment.
Yeah, that's the point. Yeah, exactly. And I find this application pretty amazing. And the more we talk to different industries, the more we discover heat processes we never thought before. I'd never thought that even pulp and paper industry does have such a high heat demand as they are having today. There are some paper sites or pulp and paper sites worldwide which have their own power plant to supply this production site just with energy, electricity, and heat. That's incredible. And the more we discover, the more we see the need for solutions like ours to help the industries to cut down the emissions.
Yeah, and it seems, we talk about things like global warming and things, right? You're actually directly going, oh yeah, we are actually. We're putting out terawatts of heat
that's crazy.
Just as a waste, right? I mean, that's the crazy part that, what I kept on learning ever since I found you guys, just an amazing amount of heat we just don't think about. It's just not on our radar, but we could power Germany with more than Germany, because we'll make all the steel factories there be more efficient too. So it's a crazy amount of heat gets wasted. Yeah. Well, amazing. I mean, this is great. What is your kind of long term? You're already deploying projects where this isn't just on a drawing board somewhere. You're doing
no. That stage we already passed 2 years ago, I think. So KraftBlock, was founded in 2014. So it's a quite old startup. But on the other hand, we are a hardware company, and developing hardware, especially energy systems, that's not like just a chip, right? It's like more like a power plant at the end, a mini power plant for the customer. But that's what it is. And it takes quite time and also good capitalization to develop, to test it, do the prototypes. That's what we did the first 6 years of our life. And then we started implementing pilots especially to the ceramics industry, but also, it sounds a bit crazy now, but also a mobile heat storage. It means you charge it in one place, put it on a truck, transport it somewhere else, and release the heat at the other side.
Would not have thought
Yeah, true. A lot of people didn't think about this, but at the end, it was not our idea. There were companies like 8 or 10 years ago, which already tried to introduce it into the market, but they could not charge that much capacity, that much heat in their storage devices, because it was only 100 degrees C, 120, 130 degrees C was too low. So there was no economics behind. We can charge up to 1,000, 1,300 degrees C, and it's completely different. And then it's also okay to transport a storage from A to B. Could be on-site, means in the same production site. If you have heat excess on one side of the plant and heat demand on the other side of the plant, it often is cheaper to transport a container instead of building new pipes and ducts and insulation and all this stuff. Or that's what we do in northern Germany. We charge heat from a small CHP. It's a biomass CHP, which is in the rural area, so no connection to any heating system, but they have heat, right? I mean, they can now charge our storage, and there's a contractor driving the storage to the customer, where this movable heat, transportable heat replaces the heating system which was installed by now, right? A gas-fired system. And it's a perfect combination, because the CHP plants should produce also heat, and they should use it. And we offer a new business model to them to supply their heat to third parties, although there is no pipe-bound district heating system available.
Right. So creating a true heat isn't really, like, you can't transport heat super long distances in a pipe. You lose it too quickly. So you're actually creating a way to buy and sell heat then as well. Hey, we don't have any secondary processes. We just have excess heat that we can't use they could actually utilize your system and go, yeah, we have all this and we can go sell it. We can sell it as a commodity.
Exactly.
You're really turning heat. I mean, that's what we do with electricity, right? We buy and sell electricity all the time. West Coast, like California, buys it from Washington State, right? We move it 1,000 miles and sell it, but we can't. But you're making it so that we can actually do that with heat now as well, and make that's awesome. That's a great. Never would have thought of selling heat or buying it, but I mean, other than in like buying a fuel to create it. But now you can skip that part and just grab all the waste heat and go sell it to whoever needs it. That's amazing.
That's exactly what it is. I love this pilot project, and it's converting now into a commercial one. So customer is absolutely happy with the solution and already ordered a couple of more of our storage containers to build, let's say, the commercial part of his new business solution. And since 1.5 years, we are commercializing our technology, right? PepsiCo, Eneco, a big Indian steel supplier is there. We execute it at the moment, will be commissioned at the end of this year. Another one in steel industry in Germany at the beginning of next year. Yeah, we are on the market now.
Amazing. What's your long-term vision for this? You finally commercialized, been doing that for a couple of years. What's the 5-10-year vision for this company? It's technology.
For the company, 10 years vision, definitely to become a gigacorn. So building a technology that's able to save 1 billion tons on carbon dioxide every year. And I think we are quite on a good way. It's more like an idealistic goal that we have, but that's what we are living for at the end. So all our core values are around sustainability and carbon dioxide emissions, cutting down emissions generally. As for the technology, our storage will look pretty different in 10 years compared to the status today. So today it's really storage, heat in, heat out. That's it. But we have much more in mind. So it will be a different system. It will be interesting to watch our journey where it goes. We have the choice, right, to create already our vision today. We have been a lot of engineering. You would have a completely new system, which is complicated to explain to the customer, to the market. It's completely new. It was never tested and all this stuff. There are a lot of arguments why people wouldn't buy such a system. That's why we said, let's cut it down to the minimum basis we need today to supply those services to the market. And that's where we are now. So with each project, we will further develop our storage device till we end up with the vision that we do have.
That's so key and important, right? You got to meet people where they are too, right? Like you said, if you could solve all the problems, but if it's too foreign of an idea, it's very hard to get anyone to actually use it. That is exciting. I'm excited to see what your end vision really is in 10 years and see where you guys have taken everyone once you've got them hooked on the technology, and then bring them forward with you as you're improving that technology. It's amazing. I'm excited to see that journey for you guys. For everyone that's watching, listening, where can people find you? What's the best way to reach out to your company if they're interested in a project or learning, working with you guys?
You can easily find us at our website, craftblock.com. So quite simple one, but also we are quite present on LinkedIn and a couple of other platforms. So happy to get in touch over there. And especially LinkedIn, for example, is for us a very extraordinary platform. And not only to present our technology as KraftBlock, but also to educate the market and educate the people. We have a lot of, let's say, video snippets on how storage could be used, not labeled by KraftBlock, but generally explained what a storage is, why it should be used, in which application, how it could work. Really just taking care about this educational part and working out pretty fine. Also, an easy way, of course, is by email, welcome@craftblock.com. Also quite simple. By phone, it's getting more complicated, but no, electronically, it's perfectly fine.
Awesome. Well, thank you so much. And for everyone listening, we'll have that in the description. We'll have all those links so you can click those. And thank you very much, Martin. I really appreciate you taking some time to talk about what you guys are doing. I think it's a important area. We need more people being aware of this and addressing our terawatts of heat that just being wasted. So
a lot of zeros, true.
Yes, that gets to be a lot of zeros. So
Yeah.
awesome. Well, thank you so much for being on. Really appreciate it.
Thanks a lot for having me, Ian, and having the opportunity to talk about solutions that are possible today, which have not been possible a couple of years ago, and hopefully helping to change our race against climate change. Thanks a lot.
Hey there, thanks for joining us for this episode. I hope that you're enjoying the content we're putting out. If you're looking for more ways to learn about this, to get involved, create your own consciously designed products, there's a couple ways that you can do that. First is our book, Conscious Design, which you'll find a link to in the description of this episode. Please check that out. Go over quite a bit of information, what the process is, how I've applied it to product design, and some really great examples of companies out there that are doing really great work, some of whom you have seen on this podcast. The other way is our course, 4 Weeks to Launch, where I peel back the curtain on how to develop a product start to finish in a way that can create positive impact rather than any negative ones. So please check that out. That is a great resource. That will also be linked in the description as well. And see you in the next one.